Hey, so today I'm going to be talking about Redis and how we can use Redis with Spring Boot to speed up some of our queries. Redis is an open source in-memory key value database system. So it stores data in memory in key value pairs, which provides us with high throughput and low latency data access. So why is Redis optimal for caching? Redis stores data in memory, making it extremely fast for data retrieval. This makes it ideal for caching frequently accessed data. So this can reduce our database load time. Okay, so I'm going to show you how we can connect Redis with our Spring Boot applications. So yeah, let's go ahead and get into it. There are going to be a few things that we will need to get this set up. What we're going to do is we're going to install Redis and create a setup for that. But we're also going to connect it with a Postgres SQL database. In order to get Redis set up on Windows, at least the easiest way to do that is install Linux on Windows with WSL. You can do this in a few ways. I think the easiest way to do this is if you're following Docker desktop installation, they will get you set up with WSL as well for Linux. But you can also follow the steps in this guide, and I will post the links in the description. Once you get WSL installed along with Ubuntu, another thing I would recommend is installing the Windows terminal. And this Windows terminal, which we can see right here, it's going to allow us to run actions on our Ubuntu VM. Some other tools that I'm going to be using is the Intellij IDE. And if you want to use this to follow along, you can install the Community Edition right here. I would also recommend on the second half of this video, I'm going to connect the Redis cache with Postgres. So you can install Postgres through this link, which I will leave in the description. So once you met all of these prerequisites, we can install Redis on Windows. And this link, which I'm also going to leave in the description, provides you with some good steps to install Redis through Ubuntu. Basically, what we want to do is once we get Ubuntu set up on our Windows terminal CLI, we can execute these following commands. I've already executed the commands on my computer, but you should be able to follow these commands here, and then you should be able to run the sudo server start. Okay, and then you can validate that your server is running by checking the Redis CLI. So Redis CLI, and once you're logged in here, you can run the ping command. And if it responds with Pong, then you are good to go. All right, once you're all set up with Redis and it's up and running, you can go into spring.io and initialize a project. So I'm going to go ahead and create a new project here. The artifact demo is going to be Redis cache demo, and then demo project for Spring Boot with Redis cache. We're also going to select, for this version, I'm going to use Java 21, and we're also going to use version 3.2.5. Gradle is going to be used as the build tool. You can use Maven as well. I'm going to add some of the dependencies. So we got web here. We have Redis, Spring Data Redis, I believe. And then we also want to add JPA. We want to add Lombok. And we also want to add Postgres. So once you have all of these things selected, you can click on the Explore option and we can look at our build.gradle to validate we've got everything we need. Okay, once you have everything validated, go ahead and download the project. And then you want to save it in a location that you are going to work with later. So for me, I'm going to be putting it in this directory here and extracting it all. All right. Now that we have the project downloaded and extracted, we can go ahead and add it into IntelliJ. So I'm going to go into File, Project from Existing Sources, and then find the folder location where I saved the project. So Redis cache demo, make sure we got the build.gradle, click OK. Make sure Gradle is selected for this one. New window. All right. So now we got the project imported and we can start working on it. Okay, now that the project has successfully been added to IntelliJ, I do want to add one more library, which is Redis. So we're going to do implementation. We're going to do redis.clients.redis. Okay. All right, so once we have Redis added into our Gradle build, let's go into the resources application.properties and let's add the following properties. So this is mostly going to be the connection properties for our Postgres application. When you create your Postgres, you're going to create a username and password. So use your username and password here. For this project, we're going to be creating a default schema called backpack, and we're going to connect to the Postgres URL Pokemon. Basically, we're going to be creating an application that tracks each user's Pokedex, the Pokemon they have in their Pokedex theoretically, and also we're going to use the Redis cache for the Pokeballs. One thing to note in this application's properties file is we set the Hibernate DDL auto to update. And what this allows us to do in a development perspective is it will auto generate some of the tables that we will create from our entities. In a production environment, you probably want to set this to none. All right, so now that we have the foundation of the application set up, let's go ahead and get everything else like our packages created. So the first thing you want to do is enable caching. And once we get this annotation added, this is going to let Spring Boot know that we want to enable caching on our applications. All right, so the next thing we want to do is create a few packages for our application. And if you're on IntelliJ, you can right click on this existing package and then go to new package. But I went ahead and created 4 packages: config, which will contain our Redis configurations, the controller for our REST endpoints, and then the entities we will use to be represented in our database tables, and the repository will be used to interact with our database. And to give us a good example of how to use this, we're going to use Pokeballs for the Redis database, and we're going to set up a Pokédex with the Postgres database. And then we're going to involve caching with all of this as well. All right, so let's go ahead and hop into our config here, create a new Java class called redis-config. Inside of this, we want to annotate it with the configuration annotation, and we also want to add enable Redis repositories. Within our Redis config, we're going to set up the connection factory. So that library imported earlier, the Jedis, we're going to use that to create our connection factory. So Jedis connection factory, give it a connection factory method name, and then we want to do Redis standalone configuration, which equals new Redis standalone configuration. The next thing we want to do is set the host name and the port. So we're going to use the default Redis configurations that were set up earlier, and that's going to be localhost. And then the port configuration, set port is 6379. Once we get all that set up, we want to return this new configuration, Jedis connection factory configuration. All right, now that we got the connection factory set up, we want to set up our Redis template, and this is going to allow us to create hash key values to store for our Redis application. Once you have Redis configured, we can start creating our entities, and these entities are going to represent the data that exists in our objects or tables. So the first entity we're going to make is the Pokeball entity. And this is the one that we're going to connect to our Redis database, and we're going to use the Redis database to store the Pokeball information. Let's add some annotations here to make things a little bit easier. So we're going to add the Lambok data, the Lambok all args constructor, and also the no args constructor. Finally, to link this with Redis, we're going to create the Redis hash. And this is important. You want to keep track of what we name this hash because we're going to be using it throughout our system. So for this, we're going to give it a Redis hash of Pokeball. We also want to make sure this implements serializable. Now let's fill out the contents of our Pokeball. So we're going to give it an ID. We're also going to give it a private string name, private int quantity, and finally private int power. All right. Once you have your Pokeball entity created, we can access it through a repository. So I'm going to create the Pokeball data access object. Since this is a repository, we're going to mark it with the repository annotation. And that hash we made earlier, I'm going to make a static string for this. Hash key Pokeball equals, and then we want to give it the exact one we put for the entity. Next thing we want to do is we want to auto wire the Redis template. So let's go ahead and auto wire that template we created from earlier. String and object. So now what we need to do is create some database operations that we can do to interact with Redis. So the first one I'm going to do is a save method. So we're going to save a new Pokeball. Gotta make sure to import that class in. And we're going to use the Redis template, ops for hash, put hash key that we created earlier, and then pokeball.get ID along with the Pokeball. And after that, we're going to return that saved Pokeball. The next method we want to do is the find all. So public list Pokeball find all. That's out. And we're going to add this little system out print to see if the caching is actually working. So initially, when the first call is made, we're going to go directly to the database. But if we enable caching correctly, which should prevent the database call from happening. So it should make our queries a lot faster. All right, so let's go ahead and return a list of Pokeballs. So return Redis template, ops for hash, values. And we're going to use that hash key we created. And we're going to stream that data in. Filter, Pokeball, class is instance of. I'm going to cast it to our Pokeball Pojo. Collectors to list. All right, so that should return us a list of the Pokeballs we have in the cache. And we also want to find a specific Pokeball by its ID. Public Pokeball find by ID. So we're going to do another system out print to see if we called it from the database or from the cache. Then we're going to return that Pokeball, if any. Ops for hash dot get hash Pokeball and the ID. All right, and then the last method we're going to do is to delete a Pokeball from Redis and the hash. So Redis template, ops for hash, delete hash and the ID, turn. Okay, so we now have our entity created and also the Pokeball DAO repository. Now we can interact with it through our REST APIs. And we're going to create some REST APIs. So I'm going to create a new class in our controller called Pokeball controller. And since this is going to be a controller, let's add the REST controller. Let's also add some logging in here. So SLF4J. And we want to set the request mapping to Pokeball. Let's go ahead and auto wire the Pokeball DAO so we can communicate with the database. So we're going to call this auto wired annotation, and we're going to import it in through the constructor Pokeball controller. So we're going to create a few REST endpoints. The first one's going to be a post, then we're going to do a put, a get mapping, and then get by ID, and then finally delete by ID. So let's go ahead and get that implemented. The first method is going to be a post mapping where we create a new Pokeball. Public ball, save, and then request body. Request body is going to contain a Pokeball JSON, and we will test these out using Postman. So another thing you want to install is Postman on your computer. And what I'm going to do is provide something we can upload to Postman to test out these REST APIs. So this next method we're going to look at is the put mapping. And with the put mapping, what we're going to do is also add the cache put option. And what the cache put option does is it's going to run the method no matter what. So it's going to hit the database, but it's also going to update the object in the cache as well. So it makes sure the cache is up to date. So we're going to do a cache put, and then we're going to set the key equals hashtag ID. And then the value is that hash we saved, the hash key Pokeball, and then the condition. So we only want this to activate if this selected ID in the cache, if it exists. So if it doesn't exist, it's not going to add it to the cache, or it's not going to, yeah. It's not going to add it to the cache because no one's requested for that information to be put in the cache. Now let's go ahead and create the method. So public Pokeball update at path variable int ID, and then the request body Pokeball. All right. So the first thing we want to do is we want to find the existing Pokeball in Redis. So we're going to use the DAO to find the Pokeball by ID. We're going to send in the ID from the request. And then we got to make sure the ID in the request also matches the Pojo, the Pokeball Pojo.getID. And then we're just going to use some bean utils to copy the properties over, the updated properties that we wish to make. Usually you might want to do something more intricate, or you might want to, yeah, use another object to transfer this information, but we're just going to keep it simple for now. So once that's updated, we're going to send the updated Pokeball to Redis to save. The next method we're going to make is for get mapping, and what it's going to do is it's going to list all of the available Pokeballs on Redis. Get all Pokeballs. And we're going to return the Pokeball DAO find all option. So this one's not going to have caching, but this next method, we are going to add caching here. So I'm going to do another get mapping, and we're going to call by ID. And in here, we're going to use the @cacheable annotation. Inside of here, we want to set the key to the ID here for the single value, and we're going to set the value to the hash key pokeball. And then we don't want to save it in the hash if the power is over 1,000, right? So we only want to save in the cache potentially more common pokeballs, I would say. So rare items, you might not pull it up as much, so that's okay to not cache it. But for items that might come up often, it would be a good idea to add it to the cache. So that's what this is doing here. So we're going to find Pokeball, path variable, int ID. We're going to return Pokeball DAO, find ID. Okay. So whenever a user makes a request for a specific Pokeball ID, if the power is less than 1,000, then we're going to cache it. We're going to save it in the cache. So if the user wants to pull it up again, we're not going to hit the database. We're going to just go into the cache to get that information. And then finally, we're going to do the final endpoint, which is the delete mapping. And in here, we want to run a cache evict. So if ID gets deleted, we don't want it to stay in the cache because that is going to give our users out-of-date information. And we're going to set this to the hash key pokeball, public string, remove path variable, int ID, and then return delete pokeball. Return the response from that, which should just be a string. All right, so everything's set up. Let's try and run this application and see if it works. So go into your main application and then run it. We'll see if we get any issues here. All right, cannot resolve all files. Oh, God. All right, let me see here. 1 second. All right, so the issue was happening because redis clients.jedis was not found, and this period doesn't belong here. We need to turn that into a column right here. So once you fix that, we should be able to run this and it should work. Let's test that out. Okay, so looks like the application started and we didn't have any issues. The next thing I'm going to do is open up Postman. And if you want to follow along, you can either just create the requests as we're going through them, or you can download this Redis Pokemon Postman collection that I created. So if you want, you can go into the source code that I'm going to leave in the description, and you can grab this JSON file. What you do with that JSON file is once you have it downloaded, you can go into Postman. You should be able to upload the collection through this import. Sorry, you got to click this import button and then find the JSON file. So let's test this out here. I can find it. So yeah, you should be able to take that JSON, post it in here, and then import it. So I could just run a replace on this, and we got this Redis Pokemon here. So the endpoints we want to test now that the application is up and running, we can test the Redis DB post first. Okay, so make sure you do the post example, and it's post HTTP localhost 8080 and then /pokeball. Once you have the post option selected, you want to go into this body tab here. You want to select raw, and then you want to do the JSON option. Once you have that all added in, then you want to add this JSON body so we can post this to our Redis database. So I'm going to go ahead and run this query with this JSON body. So let's run it, and it looks like it was successful. So we added this new Pokeball into our server. The next thing we want to do is let's get a list of this information. Let's validate that it works. So that is good here. So I'm going to put the IntelliJ side by side so we can just see the logs. Obviously, when we do a find all, we didn't do any caching. So it's always going to go to the database. But if we do find by ID, so I'm going to do another GET request, and we're going to do Pokeball, and we're going to find by ID 0. So let's see if this works. So here it made the call successfully, and it said it called from the database. Now what we should see is if this is being stored in a Redis cache, because we set the cacheable here, we won't get these DB calls. So I'm going to try and send it. And yeah, now we're not getting logs that it's pulling this information from the database. Instead, it's pulling it from the Redis cache. A good way to check to see if this object is existing in our Redis cache, we can do keys here, and we can pull in all the different things Redis is storing. So we can see that there's a cache for this Pokeball here. But since we also have our database connected to Redis, we also have other objects we're going to be storing as well, right? So yeah, now if I wanted to maybe update the quantity of how many Pokeballs we have, we can run this. And what's great about this with the cache put here is whenever this put gets run, we're going to update our cache as well. So we already know we have this Pokeball in our cache, but the quantity is 3. So if I look at this by ID, we're going to get a quantity of 3 here. Now, if I want to add more Pokeballs, let's say we bought another Pokeball, we can run this to update it with put. So I'm going to run this execution here. We can see the quantity change to 4. Now, if I go to my get by ID, we're going to also see that cache information got updated. So that's something that is pretty nice. If you might notice that sometimes your cache isn't being updated, and you might have to use the cache put option to make sure your caches get refreshed. And also like cache evict when something's being removed from your list. All right, so that is part 1 of this tutorial. The next half of this tutorial, what I'm going to do is set up Postgres database and connect it with our Redis cache so we can store our data on Postgres, but we can also cache it through Redis. So I'm going to implement that in the next steps, and I'll see you there. All right, so for the second half of this tutorial, we are going to use the Postgres database. And if you haven't already, you can install Postgres through this URL. It should look similar to this website. And once you have Postgres installed, we want to set up some configurations. So the first thing you want to make sure is you have this Pokemon DB repository, and then we're also just going to create a schema called backpack. All right, so once you have Postgres installed, it should come with this pgadmin, at least on Windows. And what I'm going to do here is go to this database, right click on it, and create. I'm going to call this the Pokemon DB. All right, and then we are also going to go into the schema option here. We're going to create a new schema called backpack. So the idea for this schema and database is we are going to store user item data, right? So like whatever items the user might have. In this case, for this tutorial, we're just going to store the Pokedex information. So like whatever Pokemon a player might have discovered, potentially, is something that we could build. But for now, we're just going to focus on one Pokedex and what Pokemon have been discovered on that Pokedex. So once you get this database and schema connected, make sure you have the connection properties added to your application properties. Should look like this here. We also want to do the DDL auto and set it to update. This way it will create our tables for us automatically if we don't have any. You can test out to make sure this connection works by running the application. And if you get a successful startup, you should be good and you should be connected. You can also see in the logs that a connection was established as well. All right, now that we know we can successfully connect to our database, let's go ahead and create a new entity here. And this entity is going to represent the table that we have in our Postgres database. So this entity, I'm just going to call it the Pokédex. And we're going to give it an annotation of entity from Jakarta and set the table name Pokédex there. And we also want to make sure this implements serializable. Okay, so now we gotta go into what parts make up a Pokemon. I grabbed this information from a CSV. I'm just gonna post it in here, and then if you guys want to add it, you can. I'll post it in a little bit. We're gonna also add these Lambach annotations here so we can easily get to the data. So we're gonna add the data, all args constructor, no args constructor, and also toString. ToString might already come with the data, but I'll just add it for readability. So inside of this Pokedex entity here, we're just going to represent everything that might represent like a Pokemon basic information here. So we got the ID, we got, so this versioning, if we change it, this version will auto increment the name, the type, total, attack, defense, special defense, what generation it is, and is it a legendary Pokemon. Now, some of this data could probably be normalized further. And if we actually look at the real data, we should probably look into normalizing it more. But for the purposes of this tutorial, I'm going to just keep it simple. Now that our entity is created, we should be able to run our application again, and it should be able to create this new table in our Postgres database. So I'm going to give this a run. You can see that it executed a create table statement here. I'm going to go into the PG admin, open up this backpack schema, go to the tables, and we'll see that we got a Pokedex column here. Can run a query on it. And it shouldn't pull anything up. So we want to do select all, whoops, from backpack. Yeah, there we go. So now, yeah, we can see the table and all the columns we created. So the next thing we're going to do is create the repository action so we can interact with this database here. All right, so back at our source code, let's go into the repository package and create a new Java class. This is going to be an interface. We're going to call it the Pokédex repository. Inside this repository, we want to annotate it with the app repository annotation. Make sure it's coming from the right package here. Stereotype repository, yep. And let's add a new hash key so we can track it with Redis. So we're going to call this hash key Pokédex. And I'm going to call it Pokédex like that. So we're going to use that for our caching here. Another thing we're going to implement, since we added the JPA library, we can import a lot of, or just extend a lot of methods that already exist. So I'm going to do extends JPA repository, and the type we're going to bring in is the Pokédex. And the identifier for the Pokédex is going to be an integer, right? Now that we got that set up, we should have a bunch of methods automatically added for us. We don't have to add anything here, but for example, if we wanted to add some methods in here, we could do that. So if we wanted to find Pokemon of a certain type 1, we can add this query here to do find by and then the type we want to locate. And then jQuery, JPA will build the query for us automatically in the background, which is pretty nice. So the entity, the Pokédex entity has been created, and we got the Pokédex repository. Now we just need to make the controller class for our REST endpoints. So Pokédex controller, and inside of this Pokédex controller, let's add the following annotation. So we're going to add some logging SLF for J, add a REST controller, and we're also going to set the request mapping to Pokédex. The next thing we need to do is auto wire in our Pokédex repository. So I'm going to call this auto wired annotation, and we're going to create a constructor for the Pokédex controller. Should be right. Right? What am I missing here? Invalid return type. Oh, I called it Pokeball controller. Should be Pokédex. There we go. All right. So got everything wired in. Let's go ahead and create the REST endpoints. I'm going to use the same pattern that I used before for the Redis database. So we're going to do a save, update, get all Pokemon, find Pokemon, and then we're also going to remove a Pokemon from the Pokédex, okay? So it should be the same pattern that we use for Redis, but let's go ahead and get that started. So we're going to do get post mapping, and then we're going to do a cache evict. It's going to be a little different here. We're going to add more stuff for our caching. So here I'm going to have a cache for our poke list. So that's going to be a cache that lists all of our Pokemon. Generally, I don't see a lot of people saving a list in a cache, but I would say it depends on how often your data is updated and changed. If the data isn't changed that often, saving a list in a cache, probably not that bad of an idea. But I'd say it all depends on the situation. So we're going to go ahead and create a post mapping for adding a new Pokemon to the Pokedex. And we're going to return Pokedex repository dot save, and then the Pokedex entry. Let's go ahead and create the next one for the put mapping. And in here, we're going to use a cache evict. We're going to use a cache evict and a cache put. So I'm going to set this value to the Poke list. And we want to evict all entries when this occurs. And then we want to do a cache put here. This will update the cache for the single IDs here. And the nice thing about the cache put again is it will run the method and hit the database, but it'll also update the cache. So that's a nice option with using the cache put. Dex, okay. And then the condition, we want to make sure it's caching. It's only adding or updating the cache for things that are already in the cache. So things that people are already looking for, we want to cache. If people aren't looking for those things, we don't want to cache it, right? So let's go ahead and public Pokedex update. And we're going to set the path variable to the ID we want to target. And we want to do the request body of the update we're going to be running. So Pokedex updated, Pokedex equals the Pokedex repository dot. First, we're going to find it by ID. Pass it the ID, or else we're going to send a null value to be returned if we don't find anything. So if the updated Pokedex input does not equal null and the ID that we are submitting for the request equals the Pokedex ID, then we'll run the update. So I'm going to set up the bean utils and copy over those properties that we wish to change. Now, usually you might want to do something more enhanced to fit your pojos than copy. Sometimes copy properties doesn't work out all the time. We might copy too many things when we want to just grab a certain amount of things to update. But anyways, once you copy the properties over and save those new updates, we should return the Pokedex. So the next thing we're going to do, which is going to be a little bit different than what we're doing with the Redis implementation, we're going to do a cache on the list here. Equals poke list. So when you're seeing up here with this cache evict, so if somebody saves a new Pokemon, we want to clear the cache or at least find out a way we can update this poke list. For now, the easiest way to do that is just clear the cache. So if somebody requests to get all of the Pokemon again, we'll just bring them a new list and then we'll store that list in the cache. And same thing with this put. If a value is updated, we're just going to clear the list in our cache. And if a user requests for the whole Pokemon list again, then we'll store it in the cache. Also, when we target separate IDs in our cache, we will do this cache put, which will update that specific ID. So right here, I'm going to go ahead and public list of the Pokedex entries and get all Pokemon. And then let's return the Pokedex repository find all here, okay? So what happens here is whenever a user tries to make a request to get all Pokemon, we're gonna first make a request to the database, but eventually we're just going to retrieve it from the Poke list, right? So I'm gonna try and log that and see if we are going from the database or if we're getting it from the cache. So I'm going to try this log. We'll see if it works or not, but there's another way we can prove it's coming from Redis, which I will show after this setup. All right, so the last two methods we need to do is the get mapping by a specific ID here. So we're going to run this get mapping ID, and then we're going to set this to be cacheable as well. I set the key equal to hashtag ID, and the value obviously equal to the hash key Pokedex. All right, and then the method Pokedex find one Pokemon by path variable ID. So this, our database is going to return an optional, or JPA repository likes to return an optional. So I'm just going to grab an optional. It might be null and might not. So we're going to get the Pokedex repository, find by ID, and then we're going to pass the ID we want it to find. And then we're going to return this optional Pokedex, or else return a null variable. Finally, we're going to do the delete mapping, and here we're going to set up some special cases when we delete by an ID. So we're going to use this caching annotation. With this caching, we can put multiple caching annotations. So I'm caching evict, and then we're going to set this to 2 of them. So cache evict key hashtag ID, and then value equals hash key Pokedex. And the other one, we're going to do a cache evict for the Poke list. So we're just going to clear the list if the user deletes something. So anytime our entities are updated, we're just going to update the whole list. And that might not be useful in everybody's case. I'd say maybe cache your list if you know the list isn't going to be updated that often. So we're going to do a public void remove and then set this path variable to the ID. And in our Pokedex repository, we're going to delete it by an ID here of the ID that we requested. And then from here, just going to log out that we removed a Pokemon by its ID. All right. So we have everything set up in our REST controller, and now we should be able to run this REST controller through Postman. If you want to try out these REST controllers on Postman, you can either follow along and add them as we go, or if you'd like, you can also go to my GitHub page, and for this project, there's going to be this Redis Pokemon Postman JSON collection. And what you can do, you can import it into your project. I've already imported it here. We're going to be going over these endpoints, this post, put, get list, get by ID, and delete by ID here. So let's go ahead and I'm just going to put this side by side so we can see it happening in action. I'm going to restart this application here. So looks like everything started up. We should be good to go. Let's try and create a new Pokemon entry to add into our Pokedex. So inside this basics folder here, the first one is the post. Here we can create a post response to this endpoint. What you want to do is go to this body here and select the raw option and then select JSON. So here we're gonna just add a random Pokemon here, Charmander, with these details. So I'm gonna set it to like 9001 because I'm gonna change the total so we can see the how caching can help us. All right, so I'll go ahead and send this response. We got the Charmander set up, and if I do a get list here, if we pay attention to these logs down here, we should see if it contacts the DB for this request or if it's going to get it from Redis. So I'm going to go ahead and request the list. The first time it's going to go and get this information from the database directly. And we should, let's see here. Okay, so we're getting it from the database, and if I run this again, we're not going to get any of those logs about extra SQL queries. We can actually see here that it's actually pulling the information from the Redis database. So that should make our endpoints a little bit faster, right? And we can also check in here in our Redis database. If I do keys and search for all, we'll see that the poke list came up. And so it's storing a list of those Pokemon. Now let's see here. So it has an ID of 1. If I do a get by ID of 1, if we check these logs, we should see these logs run a query to get it the first time, but afterwards it's going to get it from the Redis. So first time it ran, we got a SQL query. If I run this multiple times, we can see it's not hitting the database anymore, it's getting it from Redis. And I can also validate that by going into the Redis on Ubuntu, entering keys, and we can see that in the Pokedex it has a entry here for the ID of 1, which relates to this object here. So let's say we also want to update this specific Pokemon here. And we also want, when we make this update, we want all this information to be changed. So let me show you what might happen if we don't have this caching to update the caches, right? So if I comment out this part here on this update and then rerun this application here, so I'm going to update the Charmander to a Charmanderaz. Just for demo purposes, we want to keep the ID the same here, so ID 1. And I'm going to send this information out. Okay. Apparently that is not allowed. Why? All right, so the reason why this wasn't allowed because I forgot to add a parameter into our post mapping here. So I gotta add this ID and not the post mapping. We want to do that in the put mapping. So you want to update the put mapping, add this ID parameter so we can capture it. So let's go ahead and restart the application. And what we're going to do is see how the cache stores information even after it's been updated, right? So I'm going to make these changes to Charmander. We're going to change the name, and we're going to also change the total. If we look at the original, we got 9001 and Charmander. In the updated, we're going to add it to Charmander as, and the total is 9099. So let's go ahead and run that. We can see the update was successful and it also posted to the database. So that everything's good on that front. But if we look at the caching, if I did a git list here, we're going to see that the old information is still there. And that is probably not going to be good in some situations. We probably want updated information. If I also do this get by ID, we're going to also see that it's pulling in the old information. So in order to fix that, we definitely want to consider using cache evict and cache put so we can clear the list if a change happens here. And I'd only recommend doing this if you know your list doesn't change that often. If not, don't cache your list. And then here in the cache put, we're updating a specific ID. So I'm going to go ahead and rerun this again. And this time, instead of Charmander as, we're going to do Charmander as, and we're going to set this to 9,999, right? So let's go ahead and send that out. So the request was successful. We got a SQL query. Looks good. If I check my list, now it's actually pulling the updated data, right? So it cleared its cache and now it's getting the data that we just updated it with. So this helps to keep our caches updated, right? And now the final thing I'm going to do is I'm just going to go ahead and delete this. And this delete, what it's going to do is it's going to evict from both the caches. So it will clear the caches when we make a successful remove. So I'm going to go ahead and send that out. And we got a 200 response, so it looks good here. And if I do the get by ID, it should no longer show up on that cache here. And the list should also be cleared. All right, so that is my tutorial on how you can set up Spring Boot with Redis caching. This will definitely help speed up some of your endpoints, especially if you've got queries that are very popular and get hit very often. It might be a good idea to cache that information. But you also want to make sure that information is up to date. And that's the nice thing about these Spring Boot annotations is they give us the ability to evict the cache or do a put on it. So yeah,